Hello, my friends. Let's keep working on our NJSLA practice. Question number 2, Part B. Quickly recall for Part A. This question is testing you rational number and irrational numbers. So, a rational number we can rewrite as A over B form, where both A and B represent an integer. Okay, so in that case, let's see part B. Consider a quadratic function with integer coefficient and two distinct zeros. If one zero is irrational, which statement is true about other zero? Now let's see a quadratic function. We can write down the solution as x equal negative b plus minus square root of b squared minus 4ac over 2a. This formula is given in the test reference paper. However, if you can remember, it will save you a lot of time. Think about it, you might can make a song as like x equal negative b plus minus square root of b squared minus 4ac all over 2a. I'm sorry, my voice is terrible for singing, but if you can make your own song, try to remember it. Now let's see, from part A, we know that most square root, if you do not have a perfect square under here, they are irrational number. So back to our quadratic formula, where you can see we do have a part got involved with square root, right? And we also know the question said two distinct zeros, which means your b squared minus 4ac cannot be 0. Why? If this part equals 0, square root of 0 is 0. Then your x will be equal negative b plus minus 0 over 2a. Plus minus 0, you can omit it, which just one single solutions. So if they are not 0 here, now let's see. If your b squared minus 4ac is a perfect square, which square root you're going to have two square roots, two integer square roots, and then you're going to have a two integer solution. If your b squared minus 4ac is the number which is not a perfect square, then you are going to get the square root sign involved for your final solution for your x, which means one solution is going to be x equal negative b plus square root of b squared minus 4ac, because this is an irrational number. If it's not, if it's not a perfect square, which means you have to keep the radical sign here. And then second solution is going to be negative b minus b squared minus 4ac over 2a. Okay, see, if one x is irrational, then the other x must be irrational, because everything under the radical is the same. The only different, this is a positive square root, this is a negative square root. And let's go back to check our solution. If one zero is irrational, the other zero must be irrational, because if under square root is not a perfect square, which means this is an irrational number, and the other one you minus another irrational number, your x must be irrational. And in the reverse way, if one x is rational number, which means you do have a perfect square under the square root, then you're going to have the square root as an integer. Then this is rational, and this one must be rational. Think about it, they are like a twins or a pair. If one is rational, the other one must be rational. If one is irrational, the other one must be irrational. Okay, let's make a quick recall. Question number 2, which is talking about rational and irrational number. For part B, a quadratic function. Using your quadratic formula, think about it. Under square root, if it's irrational, both x's are irrational. If it's rational, both x's are rational. This is all for part B, question number 2.